Hey everyone, I just wanted to do a demo of this particular Unit 3 Piecewise function project. Uh, just want to kind of be able to help students get started with this particular project. So what I'm going to do is I'm going to do an example of choice A and choice B, and then you can kind of see how to graph it. You can see how it all fits, and then you're able to make progress creating your own versions of these graphs and to make it a fuller uh, uh, as part of the project where you have to create 5 different graphs. So what you're going to do is you're going to be selecting 4 of the 5 graphs that you're going to be choosing. And you can choose any of these 4. These are all parent functions of different families of functions. So you're going to have, there's absolute value, there's quadratic, there's cubic, there's radical, square root function, there's rational. And what you're going to do is you're going to fill in the values for these generic equations, replacing variables. So what I underlined in red, these are the values you're going to be replacing. And you're going to be replacing with numbers that are going to be relatively small. You're going to choose between -5 and 5. Maybe that's 1. Maybe this h is 4. Maybe this is -1. And then you're going to be graphing those 4 chosen graphs. And we're going to be using, I'm going to show you Desmos.com, where you can plug this into Desmos and you can pull the values on the graph, and then piece by piece you can put together your graph. So let's do one together. So this is only for demonstration only. You're going to be using different values for your project. So make sure that you don't use these values I'm using. If you do, then you're going to have to redo, because these are values that are just for the demonstration. So if you want to choose -1, if you want to choose 2, if you want to choose 5, that's all fine. But just remember that this is only for demonstration purposes, and you're going to have to choose a different values for your project. It can't look exactly like this one. So this is absolute value function. I replaced the a, the h, and the k with 2, 8, and 2. It can be repeated. We just want to have some variation of values. And now I'm going to show how we can put this into our Desmos calculator. So what you're going to do is you're going to go to Desmos.com. Let me see if I can get this screen to share a little bit more here. Okay, so you're going to go to Desmos.com, and you can hit Start Graphing. And the equation that we're using is y is equal to 2 absolute value of x plus 8. So you're going to just type this in. Y is equal to 2, and then absolute value. There's a vertical bar on your keyboard that you can use, and then x plus 8. Oops. Close the absolute value function, and then plus 2. Now, to help us see this graph a little better, what you can do is you can put your mouse anywhere on on the screen, and then you can drag it over to where it's easy for you to read. So we can see that there's a V-shaped graph. It is right at the vertex is right at -8, 2. And to help us see the order pairs a little better, what you're going to do is you're going to hit this little gear button. Okay? And once you do that, you see there's a table. See this convert to table here? We'll convert to table. And we're going to choose values that we see here. And what we're going to do is we're going to try to choose values that are in the -5 to -10 range. And I'll show you why in a minute. But right now, I'm just going to pick out values between -5 and -10. And the way that we can find those values is you can just type in whatever value you're looking for, and it'll plot that point, and it'll identify the y value for you. So -6, -7, -8, -9, and then I have -10. Okay, so we have all these values set up. So I'm going to transfer this over to my graph now. Okay, so let's go back to our, okay. Let me go back to my document camera. So as you can see here, you see how there's a vertical band here in gray. And what we're going to do is we're going to sketch the graph just like how we found on Desmos. But in the end, we're going to transfer just this portion over to our last graph. So we're going to be accumulating all these different parts from graphs 1 through 4, and then we're going to transfer them all onto the 5th graph. So I'm going to graph this first one here. This first one here is -5, 8. So I'm just going to plot these points here. Okay. -6, 6. -7, 4. Okay. -8, 2. -9, 4. And -10, 6. Okay, so we can see how this graph is taking shape here. Now, this is the graph that you're going to be put onto your paper. Obviously, you're going to be choosing your own values. And then just based off this graph, we're going to answer a series of questions. We're going to find out what the domain is. We see the domain. This graph is going to extend from negative to positive infinity. The range is the lowest to the highest y value, so we can say from +2 to infinity. The graph is continuous. The graph is increasing from this x value all the way to infinity. And the graph is decreasing from -infinity all the way to -8. Okay. And so those are the kind of the information that you're going to have to fill out based off the graph that you see. And if I want to find f of 3, I'm just going to plug 3 into the x value and get that y value. So if I plug 3 in for x, 3 plus 8 is 11. 11 times 2 is 22, plus 2 is 24. Okay. So here's an example of what this first graph could be if you choose the absolute value function. Okay. Now, again, what is between these two in this vertical band, we're going to translate this over to the 5th graph. But right now, let's look at the 2nd graph. Okay, so the second for the second graph, I'm going to choose choice B, which is quadratic function, parabola. So I'm going to replace the a, the h, and the k. I'm just going to choose values for this demonstration. I'll choose -1, 2, and 8. All right. So again, we're going to go to Desmos and we're going to create this graph. Okay, so I'm going to hit the X button so that I can get back to my to a blank page. And now I'm going to type in my quadratic equation that I just created. So y is equal to -1, parentheses, x plus 2, close parentheses. There's if you do Shift 6, it'll convert it to exponential, exponent form, and then you can put that squared there. Scroll to the right to come back down, and then I'm going to have +8. And here's my parabola. My parabola is opening down, and to help us see a little better, it looks like it's centered right at -2, 8 being the vertex. I can hit on the gear button, go to table of values, and I just want to choose regions between 0 and -5. So And again, I'll show you why we choose that value between, why it's really important just to have between -5 and 0. So I'm going to finish off what I have here. So I have 2, -8. I'm going to choose -3. That -3 will give me 7. If I plug in -4, it'll give me a y value of 4. If I plug in -5, it'll give me a y value of -1. Okay, so I'm going to copy all this down. And now I'm going to go back to my document camera. And we're going to create the second graph. So notice how for choice number 2, the band is, this vertical band is between -5 and 0. So that's why it's important that we really figure out what this portion is, because this is the portion that we're going to need for the final graph. So using the table of values that I pulled, I'm going to have -2, 8. -1, 7, 0, 4, -3, 7, -4, 4, -5, -1. Okay, I think this is enough for me to kind of trace my parabola here. Okay, so now I have my first and second graph. Oh, and then also I need to be able to fill out the bottom portion as well. My domain is always from -infinity to +infinity. We have our range from -infinity all the way to 8, because the lowest y value we see is -infinity because of the arrow pointing down to -infinity, but the highest y value is a +8. Okay, and so increasing is the graph is rising from -infinity all the way to this vertex, which is at -2. And then decreasing from -2 to +infinity, right? It's going to keep going to the right indefinitely and in the negative direction. Is the graph continuous? Yes. And if I want to find f of 6, I'm just going to plug 6 into my created parabola and get my y value. So 6 times 6 plus 2 is 8. 8 squared is -64. -64 plus 8 is -56. Okay, so now what we're going to do is we're going to take these two graphs, okay, and we're going to just transfer these points, okay, transfer these points over to my fifth graph. Okay, so my fifth graph, graph number 5. So we're just going to transfer what we see in the bands to that fifth graph. Okay. All right, so we have negative, let's see, for the first graph, we have -8, 2. Everything is going up over 2, up 1. Just filling this in here. All right, so I have from -5 to -10 accounted for this, for my first graph. So I have this portion showing, okay, and only the portion between in that vertical band. And now I'm going to translate this portion over to this graph. So -5, -1. Okay. We have -4, 4. -3, 7. into -8, and then 0, 4. Okay, so we're just going to display the parabola. Whatever the parabola looks like in that region, you're going to just create that. Okay. Let's see, I think I need a -5, 8 as well. Okay, I need one more point here. All right, so now you're going to be doing 2 more of these. So this is the first 2, and then and then for graph number 3, there's a band that you're going to have to do for another portion of the piecewise function, and then 1 more band. So I'm just kind of starting you off for the first 2, and obviously you're going to have to choose different values if you want to do absolute value and quadratic. And then you're going to fill these in. Between -10 and -5 is the absolute value. Between -5 and 0 is the quadratic. And then you just have to be able to plug these values into the appropriate piecewise function based off of the restriction. So -10 falls between -10 and -5. So -10 is going to go into this piecewise function. Plug -10 in, and we get -2 plus times 2, which is -4 plus 2. We get 4 times 2 times 2, which is 4, plus 2, which is 6. For -3 falls between -5 and 0, so we'll plug -3 in for the second piecewise function. We get -1 squared, which is 1 times -1, that's -1 plus 8 is 7, and then so on and so forth, right? Depending on where the value is and which piecewise function, you're going to be using that to determine whether to plug into one of these existing functions. Okay, and then finally, you're going to look at your finished graph and see if it's continuous. Right? Continuous means that the graph is connected. And right now, with what I have, this is not a continuous function. Right, so hopefully that will get you started. And you're going to be graded based off of being able to fill in each of the 4 graphs and then transferring those the banded portion of those 4 graphs to the 5th graph, and that will account for your project grade. All right, good luck, everyone.